space friend, I've had a realization this week. I maybe haven't had my priorities in order so far. We may have turned the lights on, sensed the temperature, and prepared to impress an alien, but we've basically done nothing to fix the much bigger issues of this broken ship. I can't have you thinking that I'm anything less than completely serious and responsible. So in order to rectify this, today we're going to focus on a much more serious problem. We're going to use an ultrasonic rangefinder to detect air leaks on the ship. The HCSR04 ultrasonic rangefinder comes in most basic 37-in-1 sensor kits. Today we're going to hook it up alongside a buzzer so we can be alerted about air leaks. While they of course use much more advanced units than this, ultrasonic waves are a real detection method used by NASA to detect spacecraft leaks. Other practical uses for this type of sensor are obstacle avoidance or security systems. An ultrasonic rangefinder measures distance using ultrasonic sound waves. Ultrasonic refers to a frequency above 20 kilohertz, which is above human hearing. The sensor uses two ultrasonic transducers. One of these is the trig pin, which acts as a transmitter that outputs ultrasonic sound pulses. The second is the echo pin, which acts as a receiver that listens for the sound waves being reflected back. The sensor has a range between about 1 inch to 13 feet. The sensor emits a 40,000 hertz ultrasound. If there's any kind of obstacle in the path of this sound wave, it bounces back to the module. The trig pin can be set to high in order to generate an ultrasound for 10 microseconds. This sends out an ultrasonic burst traveling at the speed of sound for 8 cycles. As soon as the burst is sent, the echo pin switches to a high state and waits for the sound wave to be reflected back. The echo pin will go back to a low state if nothing is returned within 38 microseconds or when a pulse is reflected back. Calculating how long the echo pin was in a high state lets us know how far the sound wave traveled, which lets us know how far away the object in its path was. Distance is calculated by speed times time. In this context, time is how long the echo pin was in a high state, and speed is just the speed of sound. The final part of our distance calculation is to divide the result by 2, since we have to measure both how long the sound wave traveled to the object and back. For this first project, all we need are 4 male-to-female jumper wires, the module, and the Arduino. Connect VCC to 5V, ground to ground, trig to 9, and echo to 10. First, let's write some basic code to see how this works. We're declaring our trig pin and echo pin as constant integers because that's not going to change, and then travel time and distance. Travel time, we're using the long data type because it's going to be able to store a number much higher than what the integer variable can store. Void setup, we're setting pin modes and turning on the serial monitor. Trig pin is our output, echo pin is our input. Under void loop, in order to initialize the trig pin, we first have to clear it for 2 microseconds, which is why we're setting it to low first. Then we send out the ultrasonic burst for 8 cycles, which takes 10 microseconds, and then we turn it back to low. Next, we're setting the duration variable to equal the pulse in function. This function takes 2 arguments, the pin and the pulse value. It can also take an optional third argument for timeout. The pin is the Arduino pin that you're reading the pulse data from, and pulse is going to be either high or low. Since we're setting the value to high here, pulse in is going to start timing once the pin goes from low to high, and then stop timing once the pin goes back to low. The return value of this function is going to be the length of the pulse in microseconds, and it returns 0 if no pulse was received. Then we calculate the distance by taking speed times time divided by 2, and then we print the distance to the serial monitor. Now let's focus on our potential air leak problem. We're going to use basically the same code, we're just going to add in a buzzer. This time we are going to need the breadboard, and we're going to need 3 additional male to female jumper wires as well as 2 regular jumper wires. On the ultrasonic sensor module, move the VCC pin from 5V over to the positive sign on the power rail of the breadboard, and the ground jumper wire to the minus sign on the power rail of the breadboard. Leave echo and trig where they are. For the buzzer, connect the S pin to 7, VCC to the positive sign on the power rail, and ground to the minus sign on the power rail. Then connect your last 2 jumper wires from the power rail over to the Arduino. The minus sign goes to ground, the positive sign goes to 5V. So the only changes we've made to this code are adding in the buzzer, so we had to add in the variable for buzzer that we're attaching to pin 7, and then setting it as an output. Then within the loop, we added an if-else statement to add the tone and the no tone functions. Tone is an Arduino function that can be connected to buzzers or speakers to generate sound waves at a specified frequency until the no tone function is called. It takes 2 arguments, the pin and the frequency, so here we're setting the frequency to 500 Hertz. You can mess around with it and change it to different frequencies and just see what that sounds like. I don't know why it's so funny. It makes me laugh every time. Nice. So for experimentation purposes, we're going to use this canned air, which I'm using safely, to pretend like there is an air leak. And then if something gets within 40 centimeters of the sensor, we're going to print to the serial monitor that an air leak was detected, and then the buzzer will go off. Air leak detected. What an absolutely productive, serious, and responsible day that we just had. And it's basically a win-win. If we have an air leak, we now have a way to detect it. And if it does happen, I'm not even worried about it because this buzzer is hilarious to me. I'm kind of hoping for it. Okay, don't let that detract from how serious and responsible I just proved myself to be.